Being recorded. Okay. All right, so I'm going to fork it over to my personal GitHub. I'm forking up. Looks like I already had it somewhere. So whatever, I'm going to clone it down. What the hell is it? All right. So I'm back in Oscar Platoon challenges. I'm going to do git clone, git clone recursion, git one, CD and recursion, and then open this up into a new VS Code window. And so we have a list of Python challenges. I'll do them in Python right now. All right. We want to do Palindrome. Is that correct? Can anybody let me know what is a palindrome again?
It's a word that's the same forward as it is backwards.
All right. Oscar is a palindrome. I'm just going to look at the original challenge. I'm sure they've got some. Allow your palindrome checker to check against palindrome sentences such as so whatever, blah, blah, blah. Okay. So same forward as backwards. All right. So we have a string. So we've got a function. I'm just trying to think right now. All right. For example, this sort is the same as this should return true. All right. So first thing, it takes in a string. If I want these to be the same, what should I do? It looks like the spaces are different. Wait, what? Forward and back rows. Is that what that is?
Each one of those. So soar was I, ear, I saw arrows. If you say that backwards, it's the same thing. And then, so those are two different palindromes.
Oh, I'm an idiot.
Yeah, they're
like,
sentences that are palindromes. You take all
totally not correct. Okay. So these are the same. All right. So it looks like a man and Panama. So what can we test for if we want these to be the same?
I think we want to get rid of everything but the letters.
So So first, get rid of letters or like spaces, special characters, etc. I don't know how to do that in Python. Does anybody know how to do that?
Yeah, I use import RE.
Import. So what is RE? Import regex?
Yeah.
We'll be covering regex tomorrow. Import RE. All right. And if I wanted to get rid of spaces,
Yeah, I did word equals RE dot sub.
So, all right. So word equals RE dot sub. What does sub do? Substitute or something?
Yes. And then the regex I used was in quotation marks / capital W.
So / capital W, like so?
Other slash. Okay, backslash. No. And then comma, replaced it with empty quotes.
Empty quotes. Oh.
So outside of that comma. Or outside of the quote. So quotes.
I don't think you need outside quotes for regex expressions.
All right. So would it be like, okay, so it's like something like this, and then you say comma, empty quotes.
Yeah, empty quotes, and then yeah, I had the regex in quotes.
All right. Well, if it works, so like something like that.
No, just the W inside its quotes, like that's / W in its quotes.
Oh, like that?
Right there, yeah.
Okay.
And then comma, the empty quotes there, and then comma. So you have empty quotes right there. Yep.
Oh, like there?
And then a comma after that.
Okay.
And then I did a string or str. And then in parentheses word, and then after that dot lower.
Like that?
outside of the parentheses.
Oh, I see.
Yeah.
What does that do?
That converts it all to lowercase, so you don't have to deal with the uppercase.
And this word, is that for supposed to be the input? Should that be string?
Yeah, it should be string. Yeah, mine was word.
Cool.
And then
Alright.
after lower, there should be quote, or quote, parentheses. Yep,
All right, cool.
that was it.
All right. Cool. Hopefully that works. All right. So I've got, for example, a sentence now that is totally lowercase with no white space and got rid of all
Non-character.
non-character. So that's gone. All the spaces are gone. The commas are gone, and everything is lower. Hopefully. All right. So now, what do I want to kind of test? I kind of want to. All right. I want to check to see if the last character and the first character are the same. So, okay. So maybe first, let's just do a check to see like, hey, if the string dot length, or I guess the word, if length of word is 1 character long, I'll return true. Because if this is only 1 character wrong, like A, that is technically a palindrome. All right. So we can do that. We can do else. We want to check the first and last character. If they're equal to one another, then we want to pass in the string, but with essentially with the last character and first character removed. So for example, if the first value is race car that I'm passing in, comes into the string, goes to this if statement. I check else if, or I can just say if first character equals last character. I can, so if, for example, race car, if the first character R equals the last character R, I want to recall palindrome, but with the last and first character removed. So I can say ace ka, then that's passed in. Then it goes through the palindrome again with ace ka passed in. If length of word character is 1, it's not. Therefore, comes to this if statement. If the first character equals the last character, if A equals A, then I want to pass in CEC with the first character and last character removed. So pass that in. Again, keep going down. Does that make sense?
Yep.
So that's just like an example input. But now how do I actually go about doing that? All right. So I can grab the first character of the string by doing word. So if the first character and last character equals the same, I can return palindrome. I really don't know how to remove. So it'd be.
Can you just use a splice?
Can you splice? Yeah. So it'd be palindrome like word. I don't know if it's 1 to, I don't know, -1 or -2 or something like that. I don't quite remember the syntax off the top of my head.
This return is just a return true, isn't it? Right here.
No, you're recalling the palindrome function, but with a shorter word because you're stripping off the first 2 that match.
I believe it'd be -1 because it's not inclusive of
Not
the last one.
inclusive. Awesome. Thank you. So yeah. So I'm returning the palindrome and I'm invoking the palindrome again, just with a new string with the first and last characters removed. So it just keeps on calling it. And I think I just keep doing that until I hit. So here's a question for y'all. What are 2 things that each recursive function needs?
Needs a
A
base,
base case.
Yep. So it needs a base case. And what else does it need?
a recursive case.
Yep. Yes. So always, like right when you're writing a function or a recursive function, always write out, okay, what's the base case? All right, the base case in this scenarios, if the word is one character long, return true. So that means, okay, that means at some point I'm going to have to be decrementing the string until it reaches a character of 1 or maybe even 2. I don't know, because I guess if it's also a length of 2, I don't know, yeah. So yeah, I think this is the base. I mean, obviously this is the base case, but you can also, I believe you can have multiple base cases. And then also the recursive case, which is at what case do you call the function again? So in this case, it'd be, this is, so recursive
I think
case.
your test is going to be if the length is less than or equal to 1 character, because at one point you're going to call it with the 2-character word, and then the next call is going to end up with a empty string.
Yeah, if length of character is less
I don't
than.
want to make it so if the length is 0, then return false.
I'm sorry, say that again, sir.
If the length is true,
Oh, yeah, you're right. It wouldn't get to a length of 0 unless the length at 2 was both the same character. Yeah, you're right.
Okay. So let's just go ahead and test this and see if this works. So we've got the word. All right. So if word dot length, I don't think that's the correct syntax for
It's,
Python.
Yeah.
Length of word is less than or equal to 1. I can return true and capital true.
but I think that test is going to be in the, hang on.
All right.
Yeah, what I did for mine, I just split them, and then after taking out all the special characters, I just reversed the word. That's the string. I reversed it and then compared the actual one with the reversed one.
So you just reversed the word. Did you use recursion using the reverse?
No.
Yeah. Okay. So yeah,
that was.
Yeah. So you can obviously
Yeah.
use like a built-in method that reverses a string, but
Okay, now, Tom, palindrome is not a recursive function. We're going to have another one, right?
we're gonna call palindrome again.
Well,
We're just getting.
Don't we want to have the calling routine that does the regex stuff, and then we get to our recursive?
You can have a separate function because obviously we're essentially running this multiple times. But for all intensive purposes, this is fine right now. But yeah, ideally you'd want a function separate that just returns, I guess.
Yeah, you would run this like regex once, and then you get into like a sub function that does the recursive calling, where you're not
Right.
regexing the same string over and over.
Right. Yeah. But just for the example of just utilizing recursion, this is fine right now.
Okay, in that case, the test for less than or equal to 1 isn't valid at that point, because I was thinking we were only calling the palindrome tester. That test has to be done after we decide that the first and last letters are correct.
This one does. I think this is actually will work still, I believe.
Yeah, because every time you pass it in, it's going to be, the length of it's going to be -2. So if it gets down to under 2, then I mean it'll return true.
Yep.
Yeah, you can do that test at the end of it.
Only if we tested the first and last letter. So if we come in with the word AB, this is going to return true.
No, it won't, because AB has a length of 2. So it'll come over here and it'll test.
Yes.
Oh,
that's right.
Okay. Let's see. Well, we'll test it. All right. So if word, is this the right syntax for grabbing
The last word, yes.
last character, and this is first character? Okay. All All right, and then if that's true, then we'll want to return palindrome with word at index 1. And is it -1?
Yeah, but that should be a
believe
colon.
so.
I think you need a
colon, not a comma.
Yeah.
Oh, yeah, sorry. Like so. Does that make sense?
Yes.
All right. So if we print just palindrome, and
You also need the else return false, otherwise it can only return true,
oh,
right?
yep.
Capital F.
F in Python.
Why is that thrown in there?
I didn't use an else.
You
I
need a
just
colon.
false outside of that if statement.
Or you can even just return false. Anyway,
Yeah, if there's no code following it, right, you don't need the else.
all right. So you can just do boop. Cool. All right, let's just see if this works. Hopefully I didn't make too many mistakes. But do you understand as far as you want to compare the first and last characters and then pass that back in, pass the word back into the palindrome function with the first and last characters removed. So each time you're passing it in, the word gets smaller and smaller and smaller. Does that make sense?
Yep.
Yes.
All right. What is it? LCD Python challenge. All right, so that one's true. Let's just do a race car. We get a couple of trues. All right, let's get rid of that and just put E or car, but E something like that. True, false. Okay. So it looks like everything's working. Just have to pass this one in there. So that one should be true. Cool. If I did like X right there, returns false.
Aren't we gonna test A/B?
Let's test AB. False. So that works. If we do test ABA, it should return true. It's true there.
And a 1 or 0 length.
Yeah, the empty string is kind of a special case. Do you think we can call that a palindrome?
No, I would probably say that is not a palindrome, right? Or
This would be the case to have like that initial regex plus like the length test there to return false if it's a blank string. But yeah, I don't know.
Yeah.
Technically, though, a blank string is the same forwards and backwards.
Right, yeah.
It depends on what you mean by string, doesn't it?
Right, yeah. Cool. So that's the palindrome recursive function. With that, yeah, let's quickly do 99 bottles real quick. Where's 99 bottles?
I've got a quick question.
Yep.
So one of the only differences from how I did that was using like whenever there was an if, I used an else statement. Just like functionally going through things, is there any need to having the else function, or does it make things tied up better, or is there any reason? Because like it seems like most of the time they're unnecessary if you're just gonna like check that and continue on. But is there any reason to like make sure you have the else statements or not, or?
So if you, the reason why we don't have else statements here is because we immediately have return statements. But if you didn't have a return statement in here, like if I was doing something like reassigning a variable or doing something like here, it would just continue going down the logic flow and going into all the all the if statements. But since we're immediately returning and exiting the function, we don't need else statements.
Got it.
So, because once it comes in here, it just immediately hits return, exits. It doesn't even go into this if statement. But if I was doing something else here other than returning, it would come into here, do its logic, then come over here and also test that. All right. All right. So def bottles. Again, I think somebody mentioned yesterday that they had to pass in, they had to keep track of the original amount in here. So, but let's actually kind of go in here.
Yeah, I just set a second variable equal to num and just called it bottles. But
Yeah. So, because we're going to need to keep track of the original amount. But I'm going to do, it's pretty much very similar to, I'm just going to paste mine in here for right now and we'll walk through it. And I'm sure there is like a more efficient way to do it. But let's see. All right. So I said, hey, if num is, so this is my recursive case. Oh. Yeah, I guess. And this is the base case. So as long as, so in here, I'm taking num such as 99. I'm assigning that to new num. Where is it? This num is greater than 1. Yep. So I'm coming in here. So 99, if 99 is greater than 1, print new num. So it's doing all of that. And then it's subtracting new num. And here is where I'm saying take one down, pass it around, blah, 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 99 bottles of beer, 98 bottles of beer on the wall. Then I'm returning bottle song again, but with the new number on it. So now it's 98 in here. It prints this stuff out again, but I need to pass in the original as well, just to keep track of the original.
That first return unnecessary.
This first return?
yeah, that's in the if statement. So it should be good.
Yeah.
But the next the return from the recursive case is the same.
Yeah, but they're two different if statements.
This is if one. So if new.
So
that if statement is nested in within that other one.
Yeah. So let's just print it off real quick and see. What is it? Bottle. Start with 10. Let's start with 5. And let's make sure this is deleted. All right. Clear.
So this is going to run until the stack fills up and quits.
Where is it?
Oh, it's decrementing.
Uh-oh. Oh, I'm an idiot. So needs 2 positional arguments. So in here, so for example, first I'm passing in 5. 5 comes in here. I'm assigning new num to 5. I'm testing to see if 5 is greater than or equal to 1. It is. Now I'm printing 5, like new num, which is 5. And this is where I'm doing, I pretty much converted my JavaScript iterative solution to like a Python recursive solution. So you have some ternary operator to test if for plural. And then, so 5 bottles of beer on the wall, 5 bottles of beer. Now I'm subtracting 1 from new num. I'm saying, hey, if new num is greater than 0, take 1 down, pass it around. 4 bottles of beer on the wall. and then I'm returning 4 in here. So 4, passing in the original, which is 5. So it comes up here, 4. Then it just, again, it just repeats this, decrements it. And then saying, hey, if, does it even reach here though?
Yeah, it makes sense because
Yeah.
once you get to equal to 1, you're gonna, obviously hit the top if statement, and then once you subtract 1 to get to 0,
Yep.
you're not gonna take 1 down and pass it around because you have 0 bottles. So then you'll go down to your base case.
Yep. Thank you. So right here is when I pass it down to like -1. Therefore, new num is, I guess, 0. And come up here, num. Yeah. Then go back down to my base case.
Oh, that's pretty tricky. Good solution though.
Yeah, like this one was when I first did it, I was like, what the hell? And then I was like, oh crap, I have to pass in an original because I thought there might be a way to keep track of it.
You could.
Yeah,
you
I
could,
did. I did variable. Instead of passing it 2 things, I just passed it the 1 and then just created a variable equal to that.
Okay.
You could make that whole thing a helper function and then have your like initial bottle song function just take in the num and then just pass in num and num where num original would go for the helper.
Yep.
Do you really need line 39? Since it's going to be running the return either way.
Ears on the wall. I believe it.
39, not
Oh,
38.
no, yeah, I'll still need to do this.
So it looks like that if new num is greater than 0 is actually a condition within if number num is greater than or equal to 1.
Sarah and I are both wondering why we have both 39 and 40.
All right. Let's see.
It's to check the condition to what happens after you subtract 1 from new num.
Yeah, that's what, yeah. So right here, because if new num is 1, and then I subtract 1 from there, I don't want to print this. I just want to go.
Yes, but either way, if it's greater than 0 or not greater than 0, you're still going to return bottle song.
Oh yeah. Yeah, I think you guys are right. So look at 4, 3, 2, 1, 1 bottle of beer. Yeah, so it still works. Yeah, thanks for catching that.
So this is kind of the same case as the palindrome, where there was code that didn't really need to be repeated, so it didn't make sense to me to have it in the recursive function. Like the stuff that's in your base case could just be a return, and everything else would be in an initial function. Is there a reason why we're avoiding having a function that does the preparatory work and the cleanup work?
That's personal preference. If you did that, good on you. But the main focus of this is to make sure you understand like the concepts of recursion. So
When I wrote this, I went to the store and got some more, and then I continued the song, which would make it kind of challenging with this.
Say it one more time.
My implementation of this was to go to the store and buy some more, and then continue singing the song. And this one terminates after you go to the store.
Your implementation was an infinite loop?
Yeah, wouldn't that loop infinitely?
Have you ever sung this song?
Not to completion.
I have a question on, I guess, some of the limitations of recursion, because so I just kind of messed around with it a little bit, and I was able to input 100, but then when I tried to input 1,000 into it, it said it reached the recursion limit, which I don't think would happen with the iterative solution, right? So like with recursion, you can only go up to a certain amount.
Yeah, essentially, whatever your machine, it's literally like the hardware in your machine, whether it has enough memory to store all the essentially all the functions like in the call stack. It's essentially like a hardware limitation on your local machine.
So but with recursion, you're going to hit that like because it takes up more memory. So you'll see that before you would in an iterative solution.
Yeah. Yeah.
You
So
you just barely did it because it was 992 more times than it displayed. You were only going for 1,000.
you slightly repeated. Yeah. I mean, I think that's just at what point so yeah, I think I can go up to say 992. There we go. And if I do it one more time, let's see if it breaks.
Probably 995 or 6 or something.
Yeah. So yeah, there are like that's one of like the performance issues of recursion is that it just takes up more memory, especially if you're dealing with large data sets. But again, that's just a hardware limitation. I've never implemented recursion in the real world, and unless you're working on like hardcore data intensive like problems, recursion is very ever used because of that reason. But yeah. But Sophia is a backend engineer at Apple, and she has to definitely take into consideration, time complexity and how efficient algorithms are. So there might be a case where she's used recursion before, or some interesting data structures to accomplish what she needed to do.
So just